In the last section, we started talking about one of the pillars of Elixir, which is pattern matching. Pattern matching is used for variable assignment. Now, we've worked through a couple small examples, but there's still a tremendous number of outstanding questions about it. So we'll talk more about pattern matching in a minute, but for right now, we also need to figure out how we're going to save a deck to our file system so that it can be loaded later on. So the purpose behind this saving functionality is just to give our users the ability to maybe write out the contents of their current deck to the file system sitting on our machine's hard drive. So the user could then close the program, open it back up later, and then use a separate load method that will write to as well to retrieve their saved deck. One of my favorite features of Elixir is that many of the methods of working on the underlying file system are part of the standard library. So you don't need to install any fancy modules, nothing like that. We can just start working with the file system right away. And there is one small catch, however, that's going to require us to take a little bit of a diversion and talk about the Elixir ecosystem. So Elixir is not a standalone programming language. In fact, all the code that we write isn't even being executed as Elixir code. So let's pull up a diagram and see what I kind of mean by that. So this is where the language Erlang comes into play. And if you've done any research on Elixir, you might see both the terms Elixir and Erlang. Erlang is a completely separate programming language that was developed many years before Elixir ever came into being. So again, the code that we write doesn't quite get executed as is. There actually are a couple steps in the whole process. The code that we write gets fed into the Elixir runtime, which transpiles all of our code into this other programming language called Erlang. So the Erlang language then compiles and executes all of our code on something called the beam. So, woohoo, a whole bunch of new terms, fantastic. Let's actually talk about them. First, let's talk about Erlang a little bit. So Erlang and Elixir have a very interesting relationship. They are two programming languages with different styles of syntax, but nearly identical underlying concepts. Erlang was developed as a solution for large telecom companies 30 years ago for handling telecom networks. So Erlang is a fantastic language, but oh man, I don't know if you've looked at any examples of it. The syntax is kind of notorious for being pretty difficult to understand. And so that's where Elixir comes into play. Elixir, as we've seen so far, has a reasonably straightforward syntax, right? There's not a lot of mystery symbols or words floating around. So you can think of Elixir as a dialect of Erlang, and we write Elixir as kind of an excuse to get away from the annoying parts of Erlang, like the parts where it's just kind of perhaps a pain in the rear to write. So all the code that we write, however, actually ends up being ran by Erlang anyways. Elixir's sole purpose is to give us a better interface to Erlang. Once we have our code transpiled or compiled down to Erlang, it is then executed on something called the beam. And so you'll see this term beam floating around all over the place in Elixir and Erlang articles. Beam stands for, and I'm going to just butcher the pronunciation here, but it's Bogdan/Bjorn's Erlang abstract machine. So it's an acronym. So basically Bogdan's Erlang abstract machine, which is Beam. Bogdan and Bjorn are the names of the guys who originally created it. The Beam is a virtual machine in which all of our Erlang code gets executed. So if you've got any background in, say, like Java, then you can kind of think of the Beam as being like the JVM. Knowing about the Beam is not a requirement for writing good Elixir code. I just want to give you a little bit of insight about how these terms actually, on how these things play together and how they work together, especially since you'll undoubtedly see references to this like beam thing in documentation. So anyways, back to the topic at hand. We are trying to mess around with the file system here by saving and then loading a file later on. The point I'm trying to make by bringing Erlang into discussion is to say that there are small bits of functionality that Elixir actually doesn't implement itself. And some areas of working in the system are just one of them. Like literally some parts of working in the system are not fully transpiled into Elixir, and we have to call some amount of Erlang code to make this stuff work. A good way to frame this is to say that we've really been working with the Elixir standard library a lot with like the enum and list modules. Those are part of Elixir. With a file system, however, we're going to be working with just a tiny bit of Erlang code. So anyways, I'm really building this up way too much, like the amount of Erlang we have to write is absolutely trivial, but I just want you to know the relationship between Elixir, Erlang, and Beam before we actually see that code pop on the screen. So let's continue in the next section and look at that Erlang code.